Hi, welcome back to another episode of Algebra in Words, the video series for YouTube. We're going to continue our discussion on linear equations. On the board right now, I have 6 linear equations. And what we're going to do is analyze them to see if we can find any that are parallel or perpendicular. So, a quick explanation about how you can look at equations to determine whether lines are parallel or perpendicular. The main thing that you want to do is to analyze the slope of each line and compare them only when the equations are in slope-intercept form, y equals mx plus b. You could look at the slope if it's in point slope formula, but you can't do it when it's in standard form. So anyway, here's how you can tell whether lines are parallel, because the slopes are identical. And how can you tell when lines are perpendicular? There's 2 criteria. You have to look at the slopes and compare them. And if the slopes are both opposite and reciprocal, opposite reciprocals, then the lines are considered to be perpendicular, meaning that they intersect at a 90-degree angle. So what is opposite? Opposite means the opposite sign. So if one slope is positive, then its opposite would have to be negative. Or if you had a negative, its opposite would be positive. And finally, what is reciprocal? Reciprocal, you should know, is the upside down of a fraction. So if you have 1/3, the reciprocal of 1/3 is 3 over 1. If you have the number 8, the reciprocal of 8 is 1/8. And finally, what about, suppose I said the fraction negative 2/3. What's the opposite reciprocal of negative 2/3? It would be positive 3/2. All right. So I have 6 equations on the board, and what we're going to do is, starting with the one on the top left, we're going to compare that to the other equations to look to see if there are any other equations here that are parallel to that line. So this equation is y is equal to 3/4 x plus 2. Well, as I was just explaining, we're focusing strictly on the slope. Is this equation in slope-intercept form? Yes. Y equals mx plus b. So we're looking at the slope 3/4. Let's go to this one. This is 3/4. This is negative 3/4. Okay, are these slopes identical? No, they're close, but they're different because this has a negative and this is a positive. So these are not parallel. What about this one? This is 4/3. Is 4/3 the same as 3/4? No, they're different. They happen to be reciprocals of each other. So they're not parallel. What about this one with this one? That's 3/4. This is negative 4/3. They're not parallel because, again, their slopes are not the same. And what about this one? Y is equal to 3 over 4x minus 3. Okay? This is 3/4. This is 3/4. So, are they parallel? Well, you might notice that they have different y-intercepts. This is 2. This is negative 3. But the y-intercepts don't matter. You're only comparing the slopes when they're in slope-intercept form. And they're the same, 3/4 and 3/4. Therefore, this equation and this equation are parallel. Let's just mark that as being parallel. Okay, and now let's compare this problem to this equation. This is 3x over 3/4 x plus 2y is equal to 7. Is this equation parallel with this equation and this equation? Think about that for a second. Well, 3/4 is in front of x, right? However, is this equation in slope-intercept form? It's actually not. This is in standard form. ax plus by is equal to c. So I put that problem up there kind of as a trick, because you have to not only make sure that the slopes are the same, but that the equations are both in the proper form, slope-intercept form. This one is not. So we cannot say that this is parallel with this. Matter of fact, if you did the math and rearranged this problem, you would actually find out that the slope of this line is I think it's -3/8. Alright, so anyway, so we figured out which equations are parallel. Now let's do perpendicular. And remember, to find perpendicular lines, we're comparing slopes that must be opposite reciprocals of each other. So let's start again with here. This is 3/4. If we look at this one, this is -3/4. These are opposites. Does that mean that they're perpendicular? No. They're opposites only, but they're not reciprocals. So therefore, this and this are not perpendicular. Now let's compare this one to this one. 3/4 and 4/3. Well, sorry, I may have said these are opposites, opposite signs. But let's compare these. These are reciprocals. 3/4 and 4/3. Does that mean that they're perpendicular? Still, it's not enough information. It's not enough criteria because they're reciprocals, but they're not opposite reciprocals. So therefore, this and this, they're not related by being perpendicular. Okay, so what about this one, 3/4, and this one, -4/3? The answer is yes, these are perpendicular because they're opposite and reciprocal. 3/4, the reciprocal of that is 4/3, and the opposite of positive is negative, so that means that they are opposite reciprocals, and let's just mark that with the perpendicular sign. Alright, and let's look at the rest. This one is 3/4, this one is 3/4. Well, they're not perpendicular because they're neither opposite nor reciprocal. It would have to be both. And we already determined that they're parallel. So perpendicular lines intersect, but we know that parallel lines never intersect. So they could never be both parallel and perpendicular. And finally, this one with this one. Well, first of all, we can't compare this slope as it is, but if we rearranged it and determined that the slope of this line was -3/8, how does -3/8 compare to 3/4? Well, they're just different. You could say they're opposite signs, but they're not reciprocals. They don't even have the same numbers. So these are not related in that way. So anyway, that's the little crash course on looking at equations and slopes to determine parallel and perpendicular lines. We'll be looking at that in a little more detail as well when we do the point slope formula in a few videos later. So anyway, that's all for this video. I hope you found it helpful. If you did, please give a thumbs up, please share it with your friends, and please subscribe to the channel so you can be alerted when new videos come out. Also check out other related videos on Facebook and Instagram, and I'll see you next time.